हेलो स्टूडेंट्स। तो आज हम पढ़ेंगे रिफ्रैक्शन के बारे में। रिफ्रैक्शन ऑफ लाइट होता कैसे है, क्या होता है और इसका यूज क्या क्या है, इसके बारे में आज हम पढ़ेंगे। तो चलिए शुरू करते हैं। व्हाट इज रिफ्रैक्शन? रिफ्रैक्शन होता क्या है? द बेंडिंग ऑफ लाइट व्हेन इट एंटर्स फ्रॉम वन मीडियम टू अनदर इज नोन एज रिफ्रैक्शन। यानी जब कोई लाइट की रे एक मीडियम से दूसरे मीडियम में ट्रैवल करती है तो वो बेंड हो जाती है। इसी फिनोमेना को रिफ्रैक्शन कहते हैं। दिस बेंडिंग occurs ड्यू टू डिफरेंस इन स्पीड ऑफ लाइट in different mediums. So the first point is different speeds. Light travel at approximately 3 lakh km per second in vacuum, but slows down when passing through materials like water, glass, or air. Second point is medium transition. When a ray crosses the boundary between two mediums with different optical properties, such as from air to glass or water, medium gets changes and the properties of the optical medium changes, results in refraction. Third point is direction change. The change in speed causes the light ray to change direction, bending towards or away from an imaginary line known as normal. So we will move further to our next point, that is cause of refraction. Refraction होता क्यों है? रिफ्रैक्शन होने के मुख्यतः तीन कारण हैं, जो कि हैं स्पीड में चेंज होना, डिफरेंट ऑप्टिकल डेंसिटीज के कारण और वेव फ्रंट बेंडिंग के कारण। चेंज इन स्पीड, जिसका मतलब है डेंसर मीडियम से जब लाइट लेस डेंस या फिर रेयरर मीडियम में ट्रैवल करती है तो वो स्पीड अप हो जाती है या उसकी स्पीड बढ़ जाती है, जिसके कारण डायरेक्शन चेंज हो जाता है लाइट का, और इसी फिनोमेना को हम रिफ्रैक्शन कह देते हैं। दूसरा पॉइंट आता है डिफरेंट ऑप्टिकल डेंसिटी। ईच मटेरियल हैज एन यूनिक रिफ्रैक्टिव इंडेक्स that determines how much it slows light. Third point is wavefront bending. So we will move to a next point, that is law of refraction. There are fundamentally two laws of refraction. The first law is the incident ray, the refracted ray, and the normal lies at the same plane. This means all the three lines are coplanar lines. अब हम आते हैं सेकंड लॉ पर, जो कि स्नेल्स लॉ के नाम से भी जाना जाता है। दिस सेज दैट द रेशियो ऑफ द साइन ऑफ एन एंगल ऑफ इंसिडेंट to the sine of the angle of refraction is constant for a given pair of medium. इसका मतलब है sin I यानी साइन ऑफ इंसिडेंट एंगल एंड sin R यानी साइन ऑफ रिफ्रैक्टेड एंगल, इन दोनों का रेशियो कांस्टेंट होगा, और इसी कांस्टेंट को हम कहते हैं रिफ्रैक्टिव इंडेक्स, a measure of how much a medium can bend light. It is denoted by mu and depends on the property of two mediums involved. Now we will move towards the next point, that is Snell's law, the rule of refraction. As we have studied that the Snell's law is one of the two laws of refraction. It suggested that sin I upon sin R is equal to constant, which is mathematically represented as mu1 sine theta 1 is equal to mu2 sine theta 2, where theta 1 is angle of incident and theta 2 is angle of refraction. Mu1 is refractive index of first medium, whereas mu2 is refractive index of second medium. Now we will move towards our next point, that is bending towards or away. The direction in which the light bends depends entirely on whether it's entering a denser or rarer medium. When a light enters a denser medium, it moves towards the normal. Here, the denser medium means a medium with higher refractive index, in which the speed of light will be slower in comparison to the other medium. The another case is away from the normal. When a light enters a rarer medium or a less dense medium, which means the medium with low refractive index, here the speed of light will be faster and the light will bend away from the normal. The example is water to air, where water is a denser medium and air is a rarer medium. The refractive index of water is written here, which is 1.33, and the refractive index of air is nearly equal to 1, which is considered just like vacuum. The refractive index quantifies this behavior. Higher means slower light and greater bending potential. Now we will move further to a next point, which is TIR or total internal reflection, a special phenomena that occurs under a specific condition where light completely reflected rather than refracted. The conditions required for the total internal reflection or TIR are as follows: denser to rarer. The light must travel from a medium with higher refractive index to the one with lower refractive index. This is the first requirement for the TIR. The second requirement is exceeding critical angle. The angle of incident must be greater than critical angle. When this happens, no refraction occurs. The third point is complete reflection. 100% of the light is reflected back into the denser medium or the same medium, we can say, obeying the law of reflection. Angle of incident is equal to angle of reflection. Now we will understand what is critical angle. The angle of incident for which the angle of refraction becomes 90 degree is known as critical angle. अब आते हैं क्रिटिकल एंगल के फॉर्मूले पे। तो क्रिटिकल एंगल का फॉर्मूला है साइन इनवर्स ब्रैकेट n2 by n1, where n1 is refractive index of denser medium and n2 is the refractive index of rarer medium. Now we will move further to a next point, that is applications of refraction. We see number of applications of refraction around the world, just like rainbow formation. Refraction plays a significant role in rainbow formation. The use of lenses used in eyeglasses, cameras, telescope, microscopes, etc. are mainly working on the principle of refraction. Fiber optics, which is very prevalent in today's world for faster internet use, are the example of TIR, where the light signal travels from long distances through minimal loss by total internal reflection. Now we will move towards our next point, that is refraction through glass slab, where the emergent ray is parallel to the incident ray but shifted sideways. Just like you can see it in this picture, where the incident light is entering in the glass slab and tilting towards the normal, and while exiting this glass slab, it will move away from the normal, which will result in the lateral displacement, which means this incident ray will be parallel to that ray. And this path is reversible path, which means it would follow exactly the same route back, demonstrating the principle of reversibility in optics. Now we will move towards the conclusion of our topic, which is refraction. So today we have learned about refraction, how refraction is helpful in our daily life, and what is the principle on which refraction work, and some laws of refraction. Thank you very much.